In 2.3, we need to find the derivative of natural log functions. So to get a general rule for doing this, we'll start with the natural log equation y equals ln x, and we'll write it up using its inverse, the exponential equation or exponential equivalent. So the base of the natural log is e, and the output of the natural log y is the exponent. It's applied to our base e, and then e to the y is equal to the input of our natural log, which is the x. So we have the exponential equivalent to our natural log equation. And to get this derivative, we're going to differentiate both sides of the equation with respect to x. So the derivative of e to the y with respect to x is e to the y dy dx, and that's an application of the chain rule. The derivative of the right side x with respect to x is just a 1. Now if we solve for dy dx with that equation here, we'll get dy dx is equal to 1 over e to the y. And since we want this derivative in terms of x, we'll notice that e to the y is x, so we can replace that e to the y with x. So here's the derivative of the natural log equation y equals ln x, and that's what the book here is calling theorem 7. Now, theorem 8 will work more generally for any statement of x, including x. That's what's meant by this f of x here, is that we don't necessarily have to have just simply x. We can have, for example, just do a simple x squared minus 5 as our input rather than x. And our rule for finding the derivative of something like this here, it says, well, and this is a chain rule application, so we're going to take the derivative of the outside piece, which is just the ln. So similar to how the derivative of natural log of x is 1 over x, the derivative of something like what I have here, natural log of x squared minus 5, begins with just putting that argument x squared minus 5 under 1. Just like how I put the 1 over x, we're going to begin with 1 over x squared minus 5. Now, to get this derivative, we also have to consider the inside component. Again, this is the chain rule. So we got to multiply by the derivative of the inside. That's our x squared minus 5, which is 2x. And this product here is the derivative of my example natural log of x squared minus 5 with respect to x, right? It is 2x, here I've listed this as y, then this here is dy dx. And we have 2x over x squared minus 5. The theorem 8 also has it written up in terms of u. A lot of times f of x and u are used interchangeably to represent statements of x. So in this case, the u was x squared minus 5. So what we ultimately did here to get the derivative was we just took the reciprocal of whatever was inside parentheses here, the argument of the natural log. We put it under 1, which is the same as taking the reciprocal. So I could do that right away for this. If I want to find the derivative, the reciprocal of x to the 9 over 5 is 5 over x to the 9. That's the 1 over u part, right, or the 1 over f of x. And then we also have to multiply by the derivative of that inside, du dx or f prime of x. Same difference. So we, again, took the reciprocal of the inside argument, x squared over x to the 9th over 5 became 5 over x to the 9th. And now we're going to multiply by the derivative of x to the 9th over 5, which it might be a little more obvious if we write this up slightly different, right? It's the same as having a coefficient of a fifth. So using the power rule, the derivative of that x to the 9 over 5 is 9/5 x to the 8th. And our derivative here can be simplified. If you notice, we have a common factor of 5. And we can also cancel out all 8 factors of x up top, leaving 1 down below. So the final answer for the first question here, f prime of x, is 9 over x. Now, the other equation, same idea. We have another statement of x as the argument of our natural log function. Rather than just x, it's 15x. Same idea. We're going to take the derivative by first finding the reciprocal of that 15x, which is 1 over 15x. And then we're going to multiply by the derivative of just that inside piece, 15x, which is 15. In this case, that product just has us canceling out the 15s. And our answer here is just 1 over x. Hopefully you found that helpful. And if you have any further questions, feel free to message me. Thank you. Bye.